We're going to take a look at one more example of Gaussian elimination for a 2x2 system. As a quick reminder, 2x2 means that we have two equations and we have two variables. Because when we represent a matrix, the number of rows is the first dimension we state, by the number of columns is the second dimension, and the number of rows that we have depends on how many equations we're faced with, and how many columns we have depends on how many variables there are in the system. So in this problem right here, we need to get this into matrix form, but it's not quite ready to be put into that form because, as we know, if we're going to be dealing with two variables, x and y, then we want to get it into an augmented matrix that looks like this here on the right. We want our coefficients of x, coefficients of y, and then our constants. It would be perfectly fine to do the coefficients of y, then the coefficients of x, and then constants. These are just the variable names, and we're just listing them in alphabetical order more than anything. Okay, so I need to get all of my variables on the left and all of my constants on the right. So if I add this first equation here, if I add 6x to both sides, I'll have 6x plus 3y equals 300. And in the second equation, if I move the 2y over, subtract it over, I have x minus 2y equals, well, there's no constant, or really the constant is 0. So even though you don't see a constant, 0 is a placeholder for it. And our second equation is 1x minus 2y equals 0, which is, again, equivalent to the second equation. So I can put my constants in here, and coefficients. So I have 6, 3, 300, 1, negative 2, 0. Now, along with my three operations, I'm allowed to swap rows, I'm allowed to scale rows, and I'm allowed to add multiples of one row to the other. Now, our first step is gonna be to obtain a 1 in this first component here. But I already see that the second row has a 1 in the x column, so what I'm going to go ahead and do is switch row 1 and row 2. And a lot of times you'll see it written like this. I'm just going to swap them, interchange them. That gives me 1, negative 2, 0, 6, 3, 300. Okay, I've done nothing more than I've just rearranged the order of the two equations. I've changed them in no way. I have not changed the equations themselves. Now, step 1's already accomplished because now I have a 1 there. So step 2 is I want to make this into a 0. I want to make that into a 0. So if I take negative 6 times row 1 and add it to row 2, store the result in row 2, notice that I'm not focusing on the y column yet. I'm really just aiming to complete this task of making this 6 into a 0. So I'm going to take, just to make this clear, negative 6 times this row, and I'm going to add it to this row right here. Okay, so negative 6 times, and leaving the first row the same. We're not changing anything there yet. We're only changing the second row. So negative 6 times 1 plus 6 is 0. Negative 6 times negative 2 is 12, plus 3 is 15. Negative 6 times 0 is 0, plus 300 is still 300. Okay, so I've accomplished step 1 and step 2. I now have the 1, 0 structure in that first column, and now I want to move inwards this way and focus on making this into a 1. Remember, we want the second row, second column, to have a 1 there so that the second row reads 0x plus 1y equals something. In other words, to get into the form y equals its value. And I see I can accomplish that by taking 1/15 of row 2 and just changing row 2 in that way. So another way of thinking about it is I'm really just dividing both sides of the equation by 15 if we were dealing with it in equation form. And so, leaving the first row the same, we have 0, 1/15 of 15 is 1. 1/15 of 300 is going to be 20. 1/15 of 300 is 20, because 20 times 15 is 300. Okay, and now that we have that, we can see that y is equal to 20. It's very tempting to want to use substitution at this point and plug in 20 for y, but we don't want to do that because a calculator is not going to do it that way. It's going to now, in its fourth step, it's going to figure out a way, and now that we have the 1, 0, 1, we want to make this a 0. We're going to pivot off of this 1. So what multiple of row 2 added to row 1 will cancel out that -2? Well, it's just going to be the same coefficient as this, but opposite sign. So we take 2 times row 2, add it to row 1, change row 1. So I'm going to write down row 2 because I'm not changing anything there. I'm just pivoting off of it. 2 times 0 plus 1 is 1. And once again, this is why we work from the leftmost column to the rightmost column, because whatever we scale the second row by now isn't going to influence the first column values at all. If we did try to make this a 1 and this is 0 first before doing anything on the first column, we're gonna be sort of taking 5 steps forward, 10 steps back, because we're going to keep undoing everything that we've changed. So by working on that first column, we set ourselves up to now be able to focus on that second column without having to worry about the first column ever again. So 2 times 1 plus -2 is 2 minus 2 is 0. 2 times 20 is 40. Plus 0 is still 40, and we're done. Once again, we just operated on the coefficients of x and y, and we changed the constants. Our first row now reads 1x plus 0y equals 40, or x equals 40. 0x plus 1y equals 20, or y equals 20. So our solution set is x comma y equals 40, 20. And the reason we call this a solution set is because we could have more than one solution for some systems, and we'll take a look at that. We'll take a look at that in another video. So there's our solution set. We can just double check that if I take 2 times y is 20, 2 times 20 is 40, and x is 40, so 40 equals 40 is a true statement. Or you can take 40 minus 2 times 20 does equal 0. And 6x, so 6 times 40 is 240. 3 times 20 is 60. 240 plus 60 is 300. And so that checks out for our second solution. Now, these coefficients will not always be perfect integers like they are here. There are situations where we end up getting fractions and we have to deal with, some pretty unfriendly looking fractions, but this is the algorithm. We've just developed the algorithm so that we can now allocate this task to a calculator or computer. It can do all of this stuff really fast. It still relies on us to do 2 things. One, we need to get it into the correct form so that we can create the augmented matrix that will feed the technology. And then secondly, once it does all of this and gets this into this special form that that is named the reduced row echelon form. So all we have to do is press a button to get it from this matrix 6, 3, 300, 1, -2, 0. And we will press a reduced row echelon form button in our computer or calculator, and we will end up with exactly what we've produced through all of these steps. And so what happens in here is this is the computer running through the algorithmic steps and then giving us the output. So we need to A, get it into this shape, and then B, be able to take it from its reduced form and interpret the solution.